This is 7-3, triangle similarity, AA, SSS, and SAS. I know we've seen SSS and SAS before, but that was with congruent triangles, congruent sides. This is going to be proportional sides now. So we'll still have congruent angles, but these S's stand for proportional sides. Okay, and the angles are still congruent. All right, so our first postulate is AA. And so AA says if we have two angles of a triangle that are congruent, we know that those triangles are similar. Really, it's AAA because of the third angle theorem. We know that the third angle is congruent as well, but we just call it AA. So two angles are congruent. We know that the triangles are similar. So I put some starred information up above, and that's really to help you through the examples in this section. We're going to look at the second piece of starred information first, that parallel lines cut by a transversal give us alternate interior angles. So in this first example to the right, we're given parallel lines, and we're told to tell if these triangles are similar or not. Well, since we're given parallel lines, we want to think about the fact that if we have two parallel lines, so I'm highlighting them for you, and I'm making them a little bit larger, cut by a transversal. There's two transversals here, but we'll look at one at a time. So let's look at PR. So parallel lines cut by a transversal give us alternate interior angles. These angles that I'm marking right now are inside the parallel lines, and they're alternate. They're on opposite sides of our transversal PR. And so those angles are congruent. But we also have another transversal, TS, and again, I'm going to extend it just so that we can see it a little bit better. And inside these parallel lines, we have alternate interior angles that are congruent as well. So now that we have our two angles congruent, these triangles are similar by AA. When we write the similarity statement, we have to be careful of how we're labeling our letters. So if I'm going to say triangle PQT is similar to triangle, and now I have to match up, my P matches R. These two match, P and R. Q stays with Q, and the T matches S. So it's going to be triangle RQS. So for side, 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 remember this is different than when we had congruent triangles. For side, side, side in terms of similarity is that the sides are proportional. And I wrote that down here for you. Sides are proportional. In order for the figures to be similar, the sides have to be proportional. So if you have all three sides being proportional, you can automatically say that the triangles are going to be similar. And for side angle side now, we have two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent. So two sides are proportional and included angles are congruent. And that's shown in the image. The included angle is in between the two proportional sides. So it would be the angle in between, and it's our SAS, just like side angle side for congruent triangles, but instead of congruent sides, we have proportional sides. But angles are still congruent. All right, let's take a look at these two examples. So for the first example, it says verify that the triangles are similar. Now it gives you the similarity, it gives you the two triangles that we're verifying if they're similar, PQR, PQR, and PRS. Okay, and we have PQ and PR, PQ and PR are proportional. QR and RS are proportional. And PR and PS, based on these letters that I'm matching up here, are proportional. And so we can set our ratio. So 4/6, which is 2/3, this 4 over 6 is 2/3, and 6 over 9 is 2/3. And so therefore, all three sides are proportional, and so this is similar by SSS. So the side lengths are not congruent, and the triangles are not congruent. We're talking about similar in this chapter. Okay, when we have two triangles, this is going back to one of the star pieces of information I had on the first slide. When we have two triangles, I want you to redraw them. So take a minute and redraw them. I'm going to pause this. And we're going to look at some information here. So the first thing I'm looking at is the length of JK. My first small triangle I redrew over here. The length of JK should be 2. The length of JL is 3, according to this image. It's 3. And the last thing I want you to see is that angle J is congruent to the angle J in the large triangle I drew because they're the same angle. So they have to be congruent. That's the reflexive property. Okay, and then the next thing that I'm going to look at, I'm going to change my color here, is the length of JM. Well, JM was this full piece, and so that's 2 and 4, which is 6. And the length of JN is 9. Okay, so now I have to see if these are congruent. Looks like I'm going for side angle side here because I have a sandwiched, an included angle. I call it a sandwiched angle in between the two sides. And remember, I don't want my sides congruent. I need them to be proportional. So I'm putting 2 over 6, the JK on the left with the JM on the right. And I'm going to set it equal to 3 over 9. And if I simplify these, 2 6 is 1/3, and so is 3 over 9. So I'm going to just put that they both equal 1/3. And so therefore they are proportional. So these triangles are similar by SAS. So when you have two triangles together and you're trying to prove that the triangles are similar, I would redraw those figures. You can see things a lot easier. So in this example, we don't have parallel lines given to us, but we do have vertical angles. Remember, vertical angles are across from each other, and they're congruent by the vertical angle theorem. So we need to verify that TXU is similar to VXW. So they're saying that this side TX, let me highlight that for you. TX, according to the similarity statement, should be proportional to VX. And VX is right here. So 12 should be over 16. And we're going to put that equal to the other proportional side. So XW, for instance, XW, the last two letters should be proportional to XU. So I'm going to put 15 over 20. And if we simplify both of these, divide this one by 4, we get 3/4. Divide this one by 5, we get 3/4. And so these sides are proportional with a congruent included angle. So therefore it's side, angle, side. And I can travel that in green so you can see it. Side, the included angle, side. Okay, side, congruent angle, side. So here we first have to see that the triangles are similar, and then we have to, based on that information that they are similar, we'll then have to find BE. Oops, it's asking us to find BE. So just looking at this figure, I already see that I have parallel lines. So I'm assuming they wanted me to know that I have congruent angles, my alternate interior angles. So there's one pair, and here's another pair. Mark that with 2 arc marks. C is congruent to E, and angle A is congruent to angle D. So by AA, these are similar. So that means that since they're similar, the sides have to be proportional. And so side AB should be matching side DB, 36 over 54. 36 over 54 would be equal to 54 for CB. Now I'm looking at this side, CB, the left triangle, to the right triangle, BE. So 54 over what I don't know, which we'll call X. And then again, solving proportions, it's going to happen a lot in this chapter. We're going to, you saw this in 7-1 as well, where we have to distribute in that case. But here we don't have binomials, so we're just doing 36 times X, which is 36X, is equal to 54 times 54, or 54 squared, which is 2,916. Divide both sides by 36 to solve for X. and we get that x is equal to 81. And so remember, x was side BE, the unknown that we were trying to find. So we know that the length of BE is 81 units.